Hello from MR-CFD. I'm glad to be here to introduce another marvelous product about the coronavirus spread due to the human cough in open air by ANSYS Fluent software. Today, the whole world is facing one of the biggest and most fundamental human challenges called corona disease. The main and dangerous problem of this disease is its high contagious power from an ill to a healthy person. The main way the disease is transmitted from person to person is through viruses in the patient's oral and nasal secretions. For this reason, doctors recommend that shake hand and hugging be severely prevented. But one of the problems is the spread of the virus through the patient's cough and sneezing in space. Now, based on the CFD method and using ANSYS Fluent software, it's possible to simulate the release of coronavirus particles from the patient's mouth during coughing. Our model involves a human placed in a cube-shaped computational domain as open air, and the human mouth is distinguished as a source of virus transmission. The present 3D model is designed using SOLIDWORKS and Design Modeler software. The meshing of the model has been done using ANSYS Meshing software, and the mesh type is unstructured. The accuracy of the mesh is higher in areas close to the patient mouth than elsewhere. In this project, two-way discrete phase model is used. The behavior of discrete phase particles in the unsteady state is also defined, and it is also assumed that the behavior of the particles is affected by the continuous flow. The physical states defined for the discrete phase model include stochastic collision, coalescence, and breakup.
Kindly like and subscribe to MR-CFD channel and tap the bell icon to get new video updates.
The droplets have a temperature of 310 Kelvin, a velocity of 31.85 meters per second, and a flow rate of 0.018 kg per second. The diameters of these particles aren't constant and equal to each other, and therefore, the Rosen-Rambler logarithmic distribution method is considered for the size of the diameters. Also, the mode of species transport is activated in order to simulate the droplet and evaporation, and thus, the working space of the model around the patient will have the airflow. According to definition of injection, virus particles from human cough are physically expelled from the mouth by water droplets that are evaporating in space. At the end of the solution process, we have obtained the particle tracking of the virus particles. This particle sequence is based on the output resistance time. Also, we have obtained and presented the images related to the virus particle sequence at different times. The results show the spread of the virus during the patient's cough, which occurs in the open air over a period of 0.1 second to 1.75 seconds.
You can obtain geometry and mesh files and also a comprehensive training video that presents how to set up the case, how to apply the appropriate solution methods, and extract and analyze the results. To benefit from MR-CFD services including simulation, consultation, and training, visit our website www.mrcfd.com or contact us via info@mrcfd.com.